Thanks everyone for coming tonight. So this is our 15th K8SUG Australia meetup. So if you haven't been to one of those events, be prepared. We're going to learn a lot of things, especially around Kubernetes. So before we start, just a tiny bit of housekeeping. So there shouldn't be any fire alarm running today, but if there's one, no exercise. So we will need to follow some of the instructions. So I'm just reading some of them. So if the alarm, please remain calm, stand by for further instruction. And if an evacuation is necessary, our fire wardens will guide you to safety using the stairwells to exit the building. So do not take the lift. That's the main keyword. So there's a designated area which is located at the corner of Collins Street and Spencer Street. And yeah, so if there's an emergency, that's what you will need to do. Hopefully nothing will go wrong tonight, apart the demo maybe. That we're used to that. Cool, so again, let's just take a moment, if the slide wants to go, to have an acknowledgement of the country. So the K8SUG Australia is respectfully acknowledges the traditional land of the Kulin Nation people, and we pay our respect to the elders, past, present, and emerging. So tonight we have two talks. We'll go on the talks, but tiny bit of introduction. So we are K8SUG, so we are a Kubernetes meetup, and we are very passionate about Kubernetes technology. So what we want to do is help you learn a lot about Kubernetes and accelerate the adoption of Kubernetes, especially in Australia. And how we do this is by learning from each other and sharing the best practices and what we do and what we learn. This time we have an army of volunteers. So we have two slides of them. So there's a bunch of us over here today to run this meetup, and this will not happen without all our volunteers. So thank you to all of them. There's the ones on this page, and then the other one, the new one, newbies who joined recently on the second page. And as you can see, some of them are looking for work. So if you are looking for anyone, any graduates or anyone in the DevOps space, feel free to reach out to them. We wanted to thank our main sponsors, so the Cloud Native Computing, CNCF, to make it short, and Code Cloud, which are the main sponsors. And for tonight's events, we would like to thank AWS for the space, and Sysdig and ControlPlane for the talks and the food. K8SUG is growing pretty quickly. So we started in September 2022 in Singapore, and since then we have opened Australia in April 2023, and Canada in August 2023 as well, and recently the K8SUG United Kingdom or London in March this year, and we have over almost 15,000 people joining those talks. In terms of upcoming events, so if you are free to travel, there's one next week in Singapore, but also if you can split yourself and do one in Singapore and one over here, there's also one here next week at Microsoft. So I think that's, Thiago, you have a, yeah, I think there's a slide after. So Thiago is going to do something special for you next week, so please join. But there's limited spaces. And then we have also on the 30th of May the K8SUG Canada, and June we still are looking for a venue in the UK, and we also have the week after another one. As usual, I don't think we're looking for volunteers anymore, or you can still try to register. We'll see when we go, but we're still looking for speakers. And you'll see tonight we've been quite lucky to have two good speakers and presenting some interesting things around Kubernetes. So if you want to have a talk or some experiences you've done, anything you've done on Kubernetes and you want to talk about it, feel free to sign up as a speaker and join us. This is a friendly environment, and if you need any help, we're happy to help you prepare, rehearse your speeches. And we're also looking for sponsors because without our sponsors, we will not have the space and we will not have the food to run this type of event. All right, so there's multiple ways of following us. I guess most of you are already on this platform, but if you haven't, we have a LinkedIn page, an X or Twitter page as well, and a Telegram group, which I haven't joined, but yeah, we do stuff over there. And yeah, before we start, I'd like to introduce Yongkang, which is going to speak a bit more about the Kubestronaut program. Please welcome Yongkang.
Thanks, yeah. Yeah, very happy to be here. Thanks, for joining us. I want to ask you guys, how many of you hold of the blue jacket? Kubernetes blue jacket or Kubestronaut? Only a few. We're not doing very good job. Yeah, I want to, most of the people can join me to become a Kubestronaut. So the Kubestronaut, basically, we announced at KubeCon in Europe. That's about 2 months ago. So far, we are, guess how many people? Initially, when we announced the program, globally, we only have 3 people. I'm kind of like the first one. You can see, if you visit the Kubestronaut, the official CNCF LinkedIn page, you can see, that's my photo. Yeah. I'd like to invite you guys, encourage you guys to join me to learn, to get certified. As long as you complete all the 5 Kubernetes certifications, it's not easy, yeah, but it's not that hard. If you're willing to learn, nothing is really hard, right? I'm one of the very first one, complete all the certifications and then become, I wear the blue jacket. I was show off at KubeCon in Paris. And then I love to take a photo, I'm a Kubestronaut, I love to take a photo with the pilots. The last week I went to Sysdig, I took a photo with, Qantas pilots. And previously I also took a photo with British Airways and also Singapore Airlines. The British Airways actually is very generous. They invited me to sit in the co-pilot seats, which I love it. I'd love to shift my focus to be more AI co-pilots, get a hold of the co-pilots stuff. So I feel like, so happy. The policy invited me to sit in the co-pilot seat. But anyway, I want to, inspire you guys to, join me to learn Kubernetes to get certified. So guess what? One of the hard parts, security. So we are very happy. We have Loris Schwartz that will talk to container security. So actually part of the certification, one of the certifications is called CKS. That's probably the hardest one. So some of the exams that testing tasks actually you need to use Falco or Sysdig tools to complete the tasks. So that's why I feel like it's such a pleasure. We can have Loris, founder of Sysdig, to join us to give a talk. Okay, so I want to show off to talk about the programs. So you guys are all from Melbourne, right? You guys can become the first Kubestronaut here in Melbourne, because I don't consider I'm the first one in Melbourne. I consider I'm the first one globally. Okay, so you guys can have the chance to become the first one in Melbourne. So in Australia, we do have one in Canberra. That's the first one in Canberra. We also recently we have another one in Sydney. Okay, so Australia we won't have 2. So it doesn't include. Okay, so not just talking about the program. I'm also previously I spent quite a lot of money to do the certification because there is no such heavy discounts. So I started helping the community to get I talk about affordable loading and the certifications. So I want to share you a few discount code. These are special only for our consumer members. You want to be able to see the huge discount from anywhere else. Did anyone join us last month or actually only this month? They surprised they gave us like a 65% off for the Google Cloud access. So previously they get us 50%. So be quick. So I believe they made a mistake. Okay. It already is 50% of, yesterday, actually today, I checked it's, 65% off. I personally recommend you guys talk to your company, ask your company. They can do code cloud business 40% off. And very importantly, if you want to do the certification, let's say a CKS, we talk about security, CKS, it's pretty expensive, $395 US dollar. So with a 46% off, we can take it down to $213, which is pretty good. I just use the CKS, CKA, and also KCS as an example. But literally any exam from Linux Foundation, you can use the code. But again, all the discount code, there is an expiration date. So try to, if you're willing to do it, be quick. That's all I wanted to talk about. But feel free to ask me if you guys have any questions. Let me hand it back to Yan.
Thanks, Yongkan. All right, so we are going on to the primary talks tonight. So just a reminder, we usually run a quiz at the end of the talk. So, and there's some prizes to win. So 2 things: stay until the end and pay extremely good attention. You will be tested at the end. And I think there's some interesting things to win tonight. So stay there. So tonight we have two speakers. The first one is Loris, who is the founder and CTO of Falco and Sysdig, and he's going to talk to us about how to navigate the Kubernetes security challenges using Falco and Sysdig. So please give a huge round of applause to Loris.
Thank you very much. My name is Loris Degionanni, CTO and founder of Sysdig. All right. I want to start maybe with a little bit of history, because the Falco story starts actually before Falco, quite a little bit of time before Falco. Falco is my second, third, the second, third open source tool of, let's say, larger scale that I've been involved with. The first one is a network analyzer, packet network analyzer called Wireshark. I see a lot of young people here, so I don't know how many of you know Wireshark. Quite a bit, okay. How many of you have used Ethereal? Only the older guys at this point. All right, so Wireshark was actually called Ethereal. I started working on that in 1999 when I was graduating at my university in Italy. I now live in the United States, but I grew up in Italy, and my graduation project at Politecnico di Torino, my university, was a packet capture driver for Windows called WinPickup, which is essentially a piece of software that you install on your Windows machine to add functionality to capture packets from a network, a wired or wireless network. And I started communicating online with this guy in Kansas City, Gerald Combs, who had built a network analyzer. I was building the packet capture driver because our computer networks professor thought that the best way to teach networks is to give people access to a network and let them observe the network, which I strongly agree with. And Gerald was building a network analyzer because he was working for a little internet service provider in Kansas City, in the United States. And network analyzer at the point were hardware devices that were very expensive, tens of thousands of dollars or more. And neither his internet service provider nor my university lab could afford a network analyzer. And so he started building a network analyzer for Solaris, and I started building a packet capture driver with a little command line tool. I actually ported TCP dump to Windows on top of my driver. And then we were like, okay, let's just start working together. At that point, overnight, Ethereal exploded in popularity because you could run it on Windows, and my driver started exploded in popularity because you could use it with Ethereal. So long story short, I got invited to the United States to do research. I was a PhD student at that point, and I met Gerard in person. We decided to start a company and start a company around Ethereal and WinPickup. The only problem was that the Ethereal domain name, website domain name, and logo trademarks were owned by the little internet service provider, which as does a sum of money that was not very big, but we were very poor essentially, and no one at that point would have given us money. So what do? We just, it's open source. One of the beautiful things of open source is that we branched the project, we gave it a new name. We wanted something that you could have good logos and mascots and so on. So why not Shark? And that's how Wireshark was born in 2006. We started the company together. That company, we grew the company for around 4 or 5 years, and then we were acquired in 2010. The name of the company was K8S Technologies. No one remembers the name of the company because everybody remembers the name of the tool. We were the Wireshark company, and we got acquired by a San Francisco company called Riverbed. I became a CTO of one of their business units, and we were selling products that were offering visibility and performance management of applications and users based on network traffic. And it was at the time a very effective way to do visibility and performance management, but not only that. I mean, if you think about packets, they are a data source that is very flexible, very powerful, especially if you can, dissect them and look at the protocols. You can understand not only what the network is doing, but what endpoints are doing, what users are doing, and so on. With packets, you can build a network analyzer, you can build security tools, you can build firewalls, you can build monitoring tools, and so on. During those days, actually, I used to say packets never lie. But the world was changing. A little company called .cloud, a platform as a service provider based in San Francisco, was renamed into Docker. The container revolution was started. This is 2013, 2014. Cloud started exploding, and enterprises really started paying serious attention to cloud, especially Amazon during those years. Google, I believe in 2014, released the first version of Kubernetes. The stack was definitely changing, evolving, and what we were doing in terms of visibility, what the industry was doing in terms of visibility, for example, using packets the way we were doing, was not architecturally appropriate anymore. When you're sitting in the cloud, you're renting computing instances, you're using cloud services. You don't have, we used to tell the users, go to the spam port of the router and span the packets, and that way we were giving the full visibility. People were starting packing. I remember our early, use cases when we started Sysdig, companies in the United States that were buying 96 core machine and putting 500 containers orchestrated by Kubernetes on each machine. When you have 500 containers talking to each other on a single machine and you're sitting on the router, a lot of the traffic doesn't even hit the network, the router. So packets were lying. And the workflows were powerful and rich, but at the same time were clearly going to be disrupted just because the architecture was changing, more layer of virtualizations, just a different way of doing things. That's what inspired me and a group of people initially to start Sysdig. And the original goal was, okay, let's see what can be the right way to instrument for visibility and for security when your primary architectural target is containers, Kubernetes, microservices, and cloud native. So if you could start from a blank sheet of paper, the first thing was realizing, okay, we cannot sit like somewhere on the network and anymore and treat everything is a black box. We somehow need to sit on the endpoint, and we need to instrument in the cloud. You need to instrument the endpoint. But at that point, if you do that while limiting yourself to packets, and in particular, what is the right way to collect data? And we started looking into techniques to instrument the kernel of the operating system, Linux specifically. And from that point of view, initially, our approach was based on a kernel module, but relatively soon we were monitoring the evolution of eBPF. How many of you know what eBPF is? All right, for people who didn't raise their hands, eBPF stands for Extended Berkeley Packet Filter. And it's sort of like a little virtual, not very little, a virtual machine that runs in the Linux kernel. And you can use to run scripts inside the kernel. The benefit of running eBPF scripts is verified before being just-in-time compiled and run by the kernel of the operating system. Verified means that, for example, the scripts have strong limitations of what they can do, because just a loop, you know, in the kernel of the operating system, depending on where it's done, can potentially freeze the machine. So it's very, you need to be very careful. And eBPF guarantees that you can run essentially extensions of the kernel that on one hand have high performance, and on the other hand are safe. And at that point, everybody thought we were crazy, because you try to do something that is for security, and then you tell people to install something in the kernel, which normally security people don't want to do. But it seemed very obvious, especially because the kernel of the operating system, you can have hundreds of containers running on top of the machine, but you can just sit in a single point in the kernel, and each one of these containers needs to go to the kernel to do file I/O, to do network, to execute commands. All of these operations, to do interprocess communication, all of this stuff requires talking to the kernel of the operating system. So you can go into a single point and maybe instrument a bunch of containers at the same time. That looks a lot like the spam port of the router. So we started building something that was based on many of the workflows that we developed for network packets. You can do captures, you can do filters, you can do all of this kind of stuff. And that was essentially the beginning. The beginning was building essentially an instrumentation architecture that would work for containers and Kubernetes. That was just like a piece of software. In fact, at the beginning, Sysdig, we were pitching it as TCP dump for the Linux kernel and for containers. But then we started looking, okay, what happened in the prior industry with packets? And one very popular way of doing security in the world of network packets is network intrusion detection systems. These are essentially tools that look at the network traffic, and they have some kind of rule engine that allows you to specify conditions like, I don't know, if a connection is coming from China and it's HTTP and it's carrying a PDF payload that then as a signature of a Perl script, then alert me. And we started thinking, you could do the same, but with the kind of information that we are collecting from the kernel of the operating system, and it could be powerful and pretty rich and pretty expressive. And that's how the idea of Falco started in 2016. We contributed Falco to the Cloud Native Computing Foundation in 2018 with the idea that this computing stack of the future is going to be Kubernetes, and excellent security needs to be embedded by default in the computing stack. And for Falco to really, be effective, it needs to be integrated perfectly into Kubernetes, and it needs to be driven by the same community. So we were accepted in Sandbox in 2018, and it took quite a little bit of time, but just a few weeks ago, Falco actually graduated. So now we are one of the top tier projects in the CNCF, which also means that the CNCF is blessing Falco for production use in any environment. Falco at this point has, well, 100 million downloads, which maybe doesn't mean a lot, but we have many users of any size, ranging from, like single users to some of the biggest brands on the planet running Falco at any scale. All right, what is Falco? Very often when describing Falco, I compare it to the security camera for containerized Kubernetes-based infrastructures. Falco is relatively simple in concept. You have a sensor that receives two types of inputs, rules and events, and that emits alerts. Events originally are system call, coming from instrumental Linux in the way that I described before. But Falco has been expanded in time with a plugin system. I will describe it a little bit later, to support arbitrary inputs so that you can ingest other stuff like cloud logs and so on. A rule is a format that is pretty straightforward. You have a description, a condition, which if you've used a tool like Wireshark or any other networking tool like TCP dump and so on, looks a lot like a packet filter, but it's a system call based filter, but it's a condition, essentially, a Boolean expression, and a condition that needs to be met to generate the output. And the output is some kind of printf-like expression that can be used to format whatever you want, and Falco will generate one of these with a context. As you can see, you can add context like the process that caused the event, or the container, or the file name, or the connection information. You have big flexibility in the way you format the output. An output at that point is emitted by the Falco sensor whenever one of the conditions is met. So in the simplest possible way, Falco just writes stuff on standard output on the same machine. So you have a sensor, you start it, it will start running and look at stuff depending on the conditions that you've defined and on the rules that you've defined. Every time there's one, you get a string on standard output. Pretty simple. From the architectural point of view, as I was mentioning, we can see a few components here. One is the libs. The libs is the instrumentation system that I was describing before. And the libs accept system calls in two different ways. One is the kernel module, the other one is the eBPF probe. But there's also a plugin input for the libs. Plugin input, we have a number of plugins now, but to give you examples, we have plugins for CloudTrail or for GitHub. So there's a plugin that looks at all of the logs through a webhook that are coming out of GitHub. Plugins for Okta, for many other tools. And so the way you deploy normally is you have a bunch of sensors, and you have normally one sensor per machine, and it's enough to have one sensor to look at all of the containers that are running on that machine. And then you have additional sensors, for example, to collect the Kubernetes audit logs. This is a plugin to collect the CloudTrail information. This is a plugin as well. And all of these essentially look at their data and emit outputs. And typically, these outputs are collected and are sent to a centralized collector. Through plugins, you can express conditions. So like conditions with system calls, sensors are like, notify me every time somebody is starting a terminal in one of my containers. Or let me know when something other than Redis server is run in one of my Redis containers. or let me know when one of the binary files in any of my containers is modified, or if somebody attempts to modify the binary file in any of my containers. These are examples. You can also do network, because of course Falco can collect network information, so you can have conditions on connections, on network domains, on files, on user activity, a bunch of stuff like that. With the Kubernetes audit log sensors, you can have Falco intersect activity in Kubernetes, execing into pods, starting pods, stopping deployments. All of this kind of stuff can be intercepted, and you can write rules and conditions based on that. Stuff like, I don't know, the CloudTrail plugin allows you to express rules like, let me know every time somebody is connecting from, I don't know, Korea without multi-factor authentication, something like that. And these plugins essentially can parse the logs in real time that are coming from CloudTrail or from the Kubernetes audit logs, and can do this kind of analysis in real time. All of the data is then, of course, useful only if it's collected and sent to some kind of useful centralized place. And what is the centralized place? Well, there's a ton of flexibility. Falco is a sub-project in the Falco organization called Falco Sidekick. And Falco Sidekick essentially sits near Falco. You can deploy one Sidekick per Falco sensor, or you can aggregate multiple Falco sensors into the same Sidekick, depending on the flexibility that you want. But Sidekick has integrations with anything that you can imagine. So, you know, all of the chats, all of the Elastic searches of the world, the Kafkas of the world, all of the metric stuff like Prometheus and so on. There's a bunch of integrations, including a new tool that we are developing called Falco Talon, which allow to integrate or create response engines. So that allows you to do automated responses based on Falco events. So I don't know, whatever. If you see a terminal started in one of my Redis containers, just kill the container. This is a simple integration, but of course can be much more elaborate and much more sophisticated than that. Sidekick is essentially, you know, like the magic door that integrates Falco with the rest of your infrastructure, allows you to collect the Falco data, allows you to do a bunch of stuff with the Falco data, and it essentially makes Falco useful for many use cases that Falco supports. All right, the company started around when we started Falco, and initially our mission with Sysdig was essentially building, you know, the instrumentation and the open source tools and community that are at the base of Falco. But of course, the mission of the company evolved quite a bit in time. And now Sysdig offers a product that is designed to heavily complement in Falco, and in particular, you know, attack the problem of cloud security in a broad way with Falco at the core of our product. From the pains point of view, there are two big pains that we try to solve with our commercial product. One is the quickness of the attacks in the cloud and the need to address them very quickly. One thing that we're witnessing, and we have a threat research team at Sysdig, and last year they did an analysis of the speed of the attacks in the data center, in a classic data center, and in a containerized cloud environment. And on average, data center attacks that we could observe would take 16 days. And on average, cloud attacks would take 10 minutes. And the reason is pretty simple. In the cloud, you know, in the data center, every stack was different, every infrastructure was different. So when somebody was able to get in, maybe through the firewall, then there was a long time to just do reconnaissance, move laterally on the network. In the data center, lateral movement is not normally network movement, go from one place to the other of the network until you find your targets and you can, whatever, exfiltrate data and so on. Now we're all using the same services offered by a handful, 2 or 3 main clouds, running, you know, with workloads that are running on well-known API-based orchestrators. Actually, one, Kubernetes, because there's only one left, and everything is much more homogeneous and standardized, which means that attacks are much more scriptable and can also be more sophisticated because the scripts evolve, you know. It's at every iteration, I mean, it's crazy. These guys know the cloud way better than us, you know. Every single esoteric service that they can use to make money, they find it and it's in the next script, you know. Like our threat research team disclosed last week an article. For the first time, we witnessed attackers actually leveraging AI services on AWS. So Bedrock, they came in, did a scan of the system, found access to Bedrock. They spawned an AI service based on Anthropic Claude, which is offered by Amazon, and then they put like a proxy in front of it, and then we could see the messages, and it was like a website for virtual girlfriends that they were charging money for in the dark web, you know. So they find a way to monetize your stuff in the cloud in a crazy way, and it's super quick, you know. It's like in 10 minutes. So how do you address this kind of stuff, you know? Okay, detection, of course, is very important. The Falco detection part is very important. But then how do you, you know, respond to something like that? And the other one is there's always a lot of noise. So, you know, people do vulnerability management, people do like compliance, all of this kind of stuff. And especially in bigger organization, it's just painful to deal with events and alerts that are constantly coming. So what we try to do at Sysdig is, first of all, Falco is at the core of our product, but we try to complement it with information that is collected in a way that is, people call it agentless. So stuff that you can collect without having to deploy the Falco sensor. Inventory information, configurations, user and identity information, vulnerabilities, all of this kind of stuff. So we collect a bunch of information that complements essentially the real-time data that Falco is able to produce. And then we take all of this stuff and we throw it in a centralized database, in particular a graph database, so that all of the information is stored in a single place, correlated in a way that you can quickly find essentially points that are in common in this information, and you can create relationships, and you can start doing queries that unveil behaviors and posture and all of that kind of stuff. And then once the data is in a centralized place, different types of data, we try to correlate it and detect combinations that tend to be toxic. Like, I don't know, it's typically, I don't know, a resource like a cloud instance or a container that is in a service that is exposed to the internet tends to be more sensitive from the security point of view. Or, you know, a container that has some critical vulnerabilities, Log4j or something like that, this one is potentially a problem too. Or you know, something that is spawning sharing containers, that's a problem too. But what if you can find places where all of these things happen together, right? So, you know, at this point, you know, a container that is internet exposed as vulnerabilities, as maybe some misconfiguration, and at the same time, you are seeing suspicious activity in it, and you're seeing that some nasty libraries are loaded, then this combination is actually pretty bad, and it's important to prioritize that compared to other stuff that individually would be a problem, but maybe not as bad as a problem. So that's what a modern security platform like Sysdig does. We try to leverage Falco and take those signals, but complement them with a bunch of other information that can make those signals more useful, more relevant, more targeted. For this, we have the concept of active cloud risk. So very often when looking at like cloud, many organizations, typically they look more like a static stuff that is based on posture and configuration. We try to put together that with the data that is coming from Falco, and we try to do it in a way that surfaces more meaningful stuff. So the game in modern cloud security tends to be very much not only in having precise detections, but having them as fast as possible. And Falco is perfect for that because it's all streaming, but also having them as accurate and with the least possible amount of noise. So that's essentially what we spend our time doing. The other thing that we do that I've personally had a lot of fun during the last year is working with AI. So AI, in my opinion, is a big deal because, well, on the attacker point of view, is just another thing that compounds on the scriptability that I was talking about. I was describing how attackers just now can write scripts that you know, do lateral movement and they can do enumeration in your infrastructure very quickly. Imagine if you had, you know, like an AI on top of your scripts that can do, you know, not only, let's say, automatic stuff, but also do stuff that requires more like judgment and step-by-step and so on. This stuff is coming, is actually already here, and makes, you know, having to secure our infrastructure even scarier and even more difficult. So it's pretty obvious that the good guys need to start leveraging these tools as well and as quickly as possible. In the long term, we'll probably have you know, AIs that attack an infrastructure that is defended by AIs, and humans maybe won't even play a role. For the time being, it's important at a minimum to have you know, AIs support you know, people that do detection, investigation, response, vulnerability management, and all of this kind of stuff. And that's one of the things that we're trying to do as Sysdig. And I don't have time to do a full demo, but I just wanted to show you because it was funny. So this is actually the user interface of the product. This is the phone. Well, first of all, I don't know if I can remove the thing that is exactly in the front. Otherwise, I can make.
Yeah, that one we don't know either.
Let's see. No.
Or you can see it on the other screen. Yeah, we can continue to see from the.
Oh, but it's a little tiny, right? What? Let me just close this window.
That works.
So this is just the screen of our product. Let's see if the network connection works. And on this side, we have Sysdig Sage, the assistant. So I'm just, a little example, but I can select an event. For example, this is actually an event that is coming from Falco. And here in this event, you can see this is there's a bunch of information, but this is the command line that generated this event. So that is, useful to receive something like that. But and there's a bunch of information here. But even just a command line like this, maybe you guys are more expert than me. I can see a mod prop, so it's probably something related to the modules. But what does this do exactly? So normally somebody in a SOG would probably Google this or go to the main page and start, trying to figure out exactly what this is. But with Sage, I can do something like just ask. Can you hear me like this? Just ask something like explain the command line in this event. Because it doesn't. And as you can see, I get a nice dissection of what the command does, what the arguments mean, and what, a contextualization in this. So as you can see, even for stuff like this, even when you're receiving events from like a tool like Falco, which are already useful, but this can save potentially a lot of work. And I can also ask stuff, a question like, I don't know, how do I remediate this? And the answer varies. By the way, is it readable, or does the font need to be bigger? Can you read it? And as you can see, I get a nice recommendation on what to do right away, what kind of investigation to do, long-term mitigation. So pretty useful, One thing that is fun is that I came here from Japan. So this week I left, San Francisco on Sunday. I did 2 days in Japan, and then I went to Sydney, and now I'm for 2 days in Melbourne. So it was funny because while we were in Japan, Japan is very rigid in terms of language. You need translators and all that kind of stuff. So this is a full-blown LLM, so you can do something like in Japanese, please, and the thing will gladly, or at least normally gladly, you see, switch to Japanese and give you this explanation, in Japanese, which was funny because people were very excited in Japan, you were getting people clapping and so on. But yeah, unfortunately, network seems to be very slow here. So it will take a little bit probably to generate the answer. But one thing that I tried on the airplane coming here was like unfortunately, for some reason, this is taking forever to generate. So I don't know if I have time to show it to you. Let's give it another 5 seconds, and if it doesn't finish. Yeah.
This is pretty cool. Any questions? Yeah.
Yeah, maybe while it generates, if you have any questions. No, it's not done yet. Either it's the network or the LLM for some reason is very slow now. Well, let's take questions.
So the AI is possible to make the capacity of my resources like CPU, memory, those things based on events.
Yeah, so let's see what the AI does when I ask a question like what I asked initially about explain the command line. The AI is instructed on what I'm seeing on the screen and where I am on the product. So as context, so that's why I can ask explain the command line in this event, because the AI knows what this event means, because we fed information about that. And then the AI queries our product, retrieves information using APIs, gets the information, typically as JSON, interprets this information, and crafts the answer in natural language. So what the AI can do and the kind of answers that it's able to give you depends on what kind of access you give to the information that we have. So this is built with the concept of assistants, essentially. And there are assistants that are capable of doing different things. And this specific assistant is able to retrieve information about like Falco events and look at the rule and look at the output and look at the condition and the kind of stuff and answer these questions. We don't have an integration for the like CPU and memory and that kind of stuff yet, but it's something that looks like we are having problems right now, but it's continuing doing it in Japanese. But it's information that it can be retrieved, and the AI, like a normal person, can go there and retrieve the information and then use it for the answers. Yeah.
How are you handling, so LLM's pretty known for hallucinating.
Yeah.
And we're providing it some context here and then asking it to tell you commands to run in your system in security context.
Yeah.
Have you any concerns with how it might hallucinate and cause greater problems by doing that?
Oh my God. Yes. The way I put it is building like a tool based on an LLM is the opposite as building a classic software product. When you build a classic software product, you build just to reach a minimum viable product, to make the first release. And then you have something that is working and you take it from there, but there's a lot of effort up front to just build something, put together a user interface, the logic and everything else. With AI, you can do an incredible demo in a day or two. It's very quick, and then you spend years and years and years just iterating to make the freaking thing stop lying. And we are not there probably 100%. It's not fully precise, but there's a number of things that we're doing. They have to do largely with restricting the domains where you use it. Make sure that for those domains you have large data sets that you can use to validate essentially what it's saying, and understanding essentially where are the areas of difficulty. Normally you can spot places where the answers are 100% or almost 100% accurate, in places where they aren't, and you do a bunch of regressions with very big data sets, and gradually through fine-tuning and prompting you improve the results. You never reach 100%, but you try to get as close as possible. There's also stuff more, let's say, bleeding edge that you can do, including maybe the LLM answer multiple times, and then have another LLM trying to pick the best answer, or doing external validation through tools that run in parallel to the LLM and so on. So there's a bunch of stuff that you try to do. Of course, in cybersecurity, the accuracy of these is much higher than the needs in terms of accuracy for something like this is much higher than when you're asking it to fix your kid's homework or write a poem. Yeah.
It stopped, Mr. Loris.
No, yeah, no, but
Can you do it in Australian?
I think I tried, and for some reason, let me try again. I really have some networking problems. It's not accepting my input, unfortunately. Oh, no, sorry. It was generating. You see. So you see, you can do localization for Australia as well. So in general, this was just, you know, a funny experiment, but it was pretty interesting how it can also do Australian, you know. The power of LLMs. This is definitely a game-changing security feature, you know, that everybody will want to have. All right, let's stop here. Let me go back to the presentation just to give you, you know, the links. So Falco is available for download at falco.org. We're on GitHub, Falco Security Organization. On the website, you find all of the links and the information that you have to participate to the community. The community is very lively. And if you decide to try Falco and you have any questions or if you want to contribute, we have a Slack channel, we have a mailing list and so on. So everybody's welcome and the community is very welcoming if you are a novice. All right, how are we doing? Do we have time for questions or is it too late? Sorry, say it again because I couldn't hear you.
No, so from online, I'm not sure if you did this, but they asked if automating the remediation based on Gen AI.
Yeah, so automation based in general is another thing that is. Oh, sorry. The question was if we are considering automation based on AI and automation of remediation. And this is definitely a super interesting topic. On one hand, we are already starting experimenting with that at Sysdig, and it's very powerful potentially. But at the same time, it's an area where hallucinations become even more critical. So if you are asking the AI to actually take action, kill a container, disabling a network connection, you know, stopping a process, that kind of stuff, then you better be sure that this AI doesn't make mistakes. I don't think we are at that level yet with the current LLMs, even the best ones, even GPT-4 and so on. It's an area where we are exploring, but I think it will take a little bit of time to be able to offer something like that. One interesting thing that I was discussing a few weeks ago is the problem is not really when the AI is like 70% accurate, so makes a lot of mistakes. The problem is when an AI is 99% accurate. Because when it's 70% accurate, you go and check your answer. When it's 99%, you assume the answer is right, and then the 1% is really, really bad, especially in cybersecurity. So the problem is, especially if you want to use these tools for active remediation, is that you need to remove that 1%, which I don't think we can do with the current technologies yet. Any other question? All right, in that case, thank you very much, Fox.
Okay, thanks, Loris, for this intro to Falco and Sysdig. We are going to move on to our second talk, if I can have the slide right. And to do the second talk, so anyway, Rob is going to speak about, give us an introduction on GitOps, and more specifically, how to use GitOps with FluxCD. So please give a huge warm up of applause for Rob.
Thank you. Can everyone hear me okay? Good evening. So, GitOps seems to be all the rage at the moment. But what is it? Why is it necessary? And how are you supposed to use it? I'm giving a talk tonight about FluxCD, but FluxCD is just one way of delivering GitOps. And so I'll talk more about GitOps and what GitOps is. First, a little about myself. Like Loris, I'll give myself a quick introduction. Is that a bit better? There we go. Cool. So yeah, a little bit about me. I've been a consultant for 5 years. I've been working with containers for 10 years, and I've been automating oil away from my tool chains for the last 20 years. When Kubernetes was released in 2007, happy birthday in June, Kubernetes, I was very skeptical. I was delivering containers through Docker and some self-scripted automation. I was orchestrating it myself. I didn't need this massive orchestration tool like Kubernetes to do what I needed to do. But my career has progressed, and I now talk to people about how they can implement Kubernetes. I've got a better understanding of what Kubernetes is, what it isn't, and how to work with it. I've also been coming to this meetup since meetup number 2 in Melbourne. So it's really cool to be up here in front of the room when normally I'm the one sitting in there watching everyone else talking. So before we go into FluxCD, and especially as everyone's just been sitting for a while, I want everyone to stand up and answer a few questions for me. So stand up, those in the back, those in the seats. This is the participation part. Wake your brains up, let's get going. So what I want to know is, how many people know what GitOps is? If you know what GitOps is, stay standing. And for all of those who don't know what GitOps is, sit down. Now, I know we've got people online, and unfortunately those online, I don't get to see whether they're sitting or standing. I can assume that they've got pants on, maybe, but probably 60% of the room has sat down in here. So if everyone's still standing, I now want you to tell me whether you're using GitOps practices and principles in your day-to-day work. If you're using them, stay standing up. If you're not using them, sit down. So if that's 40% of people who are still standing because they use GitOps, I'd say, again, 50 to 60% have sat down, if not more. So what is GitOps? And I have designed this talk for people trying to understand what GitOps is. You can sit down now, it's okay, it's okay. That's the end of my questions, it's good. So some guy said, GitOps is the best thing since configuration as code. I'd say some guy, Kelsey Hightower. Now, I first came across Kelsey when he was presenting and talking about Puppet. It said I was doing containers, and I was doing containers using Puppet to orchestrate everything that I needed to. I had humans and I had Puppet to orchestrate containers. Puppet is an infrastructure as code tool or a configuration as code tool designed for system administrators and platform engineers before we had things like Kubernetes. It's kind of moved along, but it's still designed for before Kubernetes. And so Kelsey talked at these conferences. Now, Kelsey was a Puppet user like myself initially, but he wanted to contribute to open source. And it's one of the things that I always have taken away from what Kelsey does, is his contribution to open source platforms. So he was contributing Puppet modules, and he was contributing best user guides, best practice guides. He then went on to work for Docker and CoreOS, and he has worked at Google as a developer advocate. He's been talking Kubernetes since Kubernetes was a thing. And so when he says something like this, he's someone that I listen to and try to pay attention to. And he said this on Twitter in 2018. 2018. So 2018 is when he was talking about GitOps. And yet most of the room here are either not utilizing it or don't even know what it is. Here's another one for you, and I'm not going to make you stand up this time, don't worry. Is I want to talk about CI/CD. CI/CD, continuous integration, is the process of building, testing, and generally integrating your code into a shared code repository. Everyone talks about CI/CD. CI is the integration part. CD could be continuous delivery, or it could be continuous deployment. Both kind of cover the same things. They pick up from where CI has dropped off. You've committed your code. It's been built. CD is continuous delivery is where you then build a deployable artifact. You take it through all the testing that you need to do, ensure that it's ready to be pushed to production. And in continuous delivery, you stop. In continuous deployment, you take that deployable artifact and actually deploy it in an automated way. Now that seems like the holy grail, but actually that helps set us up for what we're going to talk about next, which is GitOps. And this guy, he's popped up again, right? Again, another tweet. GitOps is version CI/CD on top of declarative infrastructure. Wind yourself back. I just said Kelsey Hightower used to work with Puppet. Puppet was configuration as code. But the big thing about Puppet as configuration as code was it was declarative. There's a way of declaring what you want your end state to be, and then having a system that can deliver that for you. You can achieve that for you. That's what he's talking about with GitOps here. He's talking about it being version CI/CD, which when you read between the lines is him saying that your CI/CD should also be declarative, because you're going to declare what the CI/CD pipeline needs to look like, and you're going to version control that so that you know when your CI/CD pipeline changed. You're going to declare your infrastructure. Where are you going to declare all these things? You're going to put it into code and chuck it into a Git repository. Look at it now. Your CI/CD is in a Git repository. Your application, your developer's already putting that into a Git repository. Your infrastructure, it's in a Git repository. Your environment is now defined in a Git repository. So if we're putting all these things into Git, what shouldn't we put into Git? Can anyone tell me? Secrets, I heard it. Secrets should never be put into Git. Sure, there's ways of encrypting it, and then you can put them into Git encrypted, but secrets should never be put into Git in a plain text format. As much as we want to put GitOps for everything else, Git for everything else, don't put secrets in Git. So it's all well and good using Kelsey and my own experience to define what GitOps is, but engineers have been debating and discussing what GitOps looks like to them pretty much since Weaveworks declared what it was or coined the phrase in 2017. Now it makes sense why Kelsey was tweeting about it in 2018, saying it's the best thing ever. So if everyone's debating it, then we need to come up with a way of defining it that everyone can agree to. And the CNCF tried to do exactly that. The app dev SIG decided that they wanted to form a working group, conveniently named the GitOps Working Group. And that working group got together to find a vendor neutral way that was principles-based to define what GitOps is. And the 4 principles that they came up with was that it must be declarative. The system managed by GitOps must have its desired state expressed declaratively, they say. And that goes back to what I was saying with the declarative code. It's a way of writing it down so that a system can make it do exactly what you've, or make it appear to be exactly what you've said it will be. They also say that it should be versioned and immutable. The second principle is that it's versioned and immutable. Hark back to Kelsey Hightower's quote. He talked about version CI/CD. So when they define what this is, they're saying that desired state is stored in a way that enforces immutability, versioning, and retains complete version history. Does that sound like Git to anyone? Yeah, I thought so. It should also be pulled automatically. Now this becomes a bit of a contentious point because there are 2 models to Git that we'll come to in a minute. So they say that it should be pulled automatically, and software agents automatically pull the desired state declarations from the source. The 4th pillar that they talk about is that it's continuously reconciled. Continuously reconciled. That's where you take your declaration and you make how it actually is running look like that declaration, reconciling the difference between where the state of the current system is and where you defined that it should be. So a little bit on the why use GitOps. We talked about what GitOps is. Now we want to think about why we should be using GitOps. There are benefits. And the first one that everyone thinks to talk about is that you can deploy faster and more often. But every tool around the world, every tool that I've ever seen that talks about DevOps or GitOps or CI/CD talks about deploying faster and more often. The way that you achieve this is actually by doing continuous delivery, the CI/CD component, and also because you've consolidated all your tooling. So in DevOps, we talk about consolidated tooling, sharing tooling. By consolidating the tooling and putting everything into Git, it makes it so much easier to deploy things. So you can deploy faster and you can deploy more often with less friction. Error recovery. If everything about your environment is defined in Git, all the way from the application that you're using, the version of the application you're using, to the environment configuration variables that you want, which service mesh it's tying into, what API endpoint it's reading from, which is going to be different in production or non-production. All of these things get tied into the configuration, stored in Git, version controlled, so you can then deploy each of those things exactly as you want it to be every time. So if something goes wrong and you discover you've misconfigured it, or your application doesn't quite work as you expected it to, you can roll back, and you can roll everything back to the same point where you know it was working. GitOps also gives you stronger security. It's great to be talking after Laura tonight and everyone thinking about security. GitOps helps you start to achieve some of that security. Falco is more about the runtime. Sysdig looks at runtime and pre-runtime. But when we're talking about stronger security in GitOps, it's having the ability and the confidence that everything that's gone through your pipeline to be deployed has gone through all of the security steps that you want, and nothing can get into your cluster unless it's gone through that pipeline. By using this pool model that we're talking about as part of the pillars as well, you know that the cluster that's pulling this information from Git is the only thing that can build anything in your cluster, except for some super admins who might have privileges. So no longer do you have developers with their own kubectl login reaching out and typing things into the kubectl command and defining what the environment looks like that's outside of code. The fourth benefit that I wanted to talk about is auditability. If your developers can't change things on the system and your sysadmins find it really difficult to change things on the system in your Kubernetes cluster, then you can see exactly what has changed, why it's changed, how it's changed, who changed it, why they changed it, because they've put in a good comment. You can tie that exact point in time that it's changed to metrics and performance. So you can see what particular change it was that caused the spike in your performance and made sure that none of your customers could actually access the website for 20 minutes. So that's why. Let's talk about how. Not surprising, the core of GitOps is based on code repositories or Git repositories. The default when you're deploying most of the GitOps tools that I've come across is to have a mono repo structure. Everyone talks about this mono repo, pulling together all of the code into a single repository, whether that's your application code, your infrastructure code, your environment code. It brings it into one location, which means that everyone can see for production all of your application code. That's fine when you're small. As you start growing bigger and as you start having more complex things and more teams of people dealing with that, it's actually better to start running a different model and not having a mono repo. When you get to that stage, you can have a platform team that looks at the platform side of it. They still have their environmental variables that they need to store in Git. They still have the infrastructure that they're managing. They still have the tooling that people will need to use. And so they'll have their own repository for that platform. And then if you're still relatively small, you'll have a developer team who are responsible for all of the applications that sit on your platform. And that team has their own repository with all of the applications in. As you grow bigger still, that application team split down into multiple different application teams. And each of the different applications that's going to get deployed through a GitOps process has its own repository. GitOps handles all of this fine. It can still pull together all of the different things, all of the different repositories, all of the different sources of truth that it needs to, and know about when it should be deploying things to which area. The other key factor when we're talking about how to deploy using GitOps is push versus pull. GitOps can be implemented in a push model where your environment definition is derived from things that you've got in your Git repository. This aligns closer with a traditional CI/CD pathway, whereby you can make a change, push it into your Git repository, build a container that then has a tag, and then you have a deployment pipeline that reads that tag, updates a deployment repository, and determines that this now needs to go to this specific cluster or that specific cluster. Your dev cluster for banking apps, your prod cluster for retail apps. And it determines as part of the deployment pipeline where it's going to go and automatically does it. For it to be able to do that, your deployment pipeline needs to have God level-like access into every cluster that you own so that it can push code into all of those clusters, so that it can build the infrastructure that you need in all of those clusters. And that's why when we think about a security side of things, the pull model is much better at security, is much more robust with security. In the pull model, you bring in something called an operator. And we all know what Kubernetes is like. There's operators galore. With a GitOps operator, that gets installed into the cluster. It's then able to pull away from all of the source repositories that you've described and determine what needs to be done in that local cluster and doesn't need to worry about all of the other clusters. It only focuses on the cluster that the operator is installed in. Now, if you want to break it down and have an operator per namespace, you can do that. And it can have access permissions just for that namespace, or it can have cluster-wide permissions. But it's still pulling what it needs for its local area, which means the blast radius of the credentials for that user getting exposed is much smaller. All right, we're really familiar with GitOps now. I can see people glazing. I can see people going, yes, this would be great if only we could use it. Well, how are you going to use it? This is where Flux comes in. So Flux goes a little bit beyond that GitOps approach. Flux is a tool. It's an operator agent running inside your cluster in the way that I just described. It keeps your cluster in sync with the repositories and once bootstrapped. So the first thing you have to do when you install Flux is you have to bootstrap it. You have to have that admin level access into the cluster to install something as a super admin. But the moment that you've done that, it creates a repository which holds its own configuration. And it then sits controlling itself using that repository, not using a super admin logged into the system. So at that point on, you shouldn't need to log into your Kubernetes cluster anymore. In addition to some of the standard benefits of using GitOps, Flux looks at more than just code repositories. It looks at OCI repositories. It looks at Helm repositories. It monitors all of these different places that you might have an update. And it's got the ability to then make a change to your environment configuration. Now, this works really great in non-prod, but I wouldn't recommend doing anything like this in prod. Because what you can do is you can set Flux up to observe the new images, whether that's a CD patch application that one of your developers has just pushed, or whether it's come from somewhere else for software that you're using from a third party. And everyone's worried about third parties at the moment. The Flux see that it's there with the Flux image scanning tool. It then pulls the latest version of the environment configuration. It makes changes to the environment configuration and pushes it back to Git. It doesn't make any changes in your cluster at this stage. It pushes those back to Git. and it uses a tool called the Flux Cluster to get reconciliation to do that. And then, as if a developer has updated these things, Flux reads it from the repository and starts applying it across your cluster. You could have a gatekeeper there at that point saying, make sure that it's been merged and there's requests and approvals before it goes any further. But in a non-prod environment, it's really useful to be able to just take your application that you've just patched, create the image in your repository, and have Flux then observe that it's there and automatically deploy it. I've worked with development teams that spend half a day when they're trying to test one tiny little thing that needs to be changed in the cluster. And they have to build their application in their own development environment. Then they have to push it through the CI/CD process so they get an image. Then they have to take that image and update it in their environment repository, and then let that run through, get all of the approvals, get all of the changes, and eventually, with lots of bits of work done, but a lot of time spent doing nothing, they get to be able to test that small change that they made. With a system like this, you're able to make the change, push it, go away for a coffee, come back, and hopefully it's deployed into your non-prod environment, start testing and see if it's doing what you want. Speaking of controllers, FluxCD is part of a toolkit. It's part of a toolkit that has other things in it, not just the FluxCD controller, not just the image scanning controller that I talked about. There's so many different things that Flux GitHub repository organization shares as an open source toolkit. But it's all designed for you to be able to take what they've got, all the tools that they've got there, pull them down and use them for yourself. Whether that bootstraps your own GitOps processes, or whether it gives you the ability to start writing your own tools that meet your environment and your configuration and the way that your team works. The toolkit is there to provide all of those little pieces, bring it together, and make it really accessible for you. One thing that I've learned as I've been discovering more about Flux is something called Flagger. And it's one of the things that I'm now going to go and dive deeper into. Because we've talked about continuous delivery. But the next stage on from continuous delivery is progressive delivery. And this hits what most people will think of as the Holy Grail. This is where you start getting your canary deployments, your blue-green deployments, your A/B testing. The developers know that they need to be trying to do, and teams have always wanted to do. Well, Flagger is one of the tools that Flux offers that is able to then integrate with your service mesh. It's able to integrate with Envoy proxies or Istio. It's able to look at your networking layer, and it's then controlling the traffic and the deployment through your cluster in lockstep with the changes and how the traffic flows, so that you can do a canary deployment. And when you hit the correct number of successful pages, you start expanding the canary out and deploying it elsewhere. By having Flagger, it looks like it's going to be an amazing progression in terms of controlling all of those things. I'm really excited to look further into that tool. All right. Page hasn't changed yet. There we go. There's another reason why I'm standing up here as ControlPlane talking about FluxCD. ControlPlane believes that open source maintainers, the progenitors, the stewards of production code running on critical systems, we believe that they require the support of a commercial entity. When Weaveworks unfortunately had to close earlier this year, ControlPlane was able to step in and employ some of the core maintainers of the Flux project. Weaveworks, who coined the phrase GitOps, wasn't able to continue. And with the Flux project having gone graduated at the CNCF, lots of people were using it. So it needs to have that commercial offering. It needs to have someone to maintain it, someone to run the infrastructure for the tests to occur on, to build each of the images out so that people can pull it down and use it for free. And so ControlPlane stepped in to do that. We employed 2 of the core maintainers. We're offering additional resources. We're offering hardening guides, policy packs to enhance GitOps for users because we've been dealing with GitOps for a while. And we're also offering enterprise packs now so that we can support Flux being used in enterprises with hardened images, assured compatibility, SBOMs, CVE patching, all of the things that we need as a security entity. We're able to provide that for Flux, so you're not worrying about using an open source tool in this capacity. So finalizing my talk with a little bit about ControlPlane. ControlPlane has around 60 people spread across the world, predominantly in Europe and the UK, a little bit in North America, and a little bit over here in the APAC region. But we get involved in some of the biggest security conferences around the world. And we've got security at our core. We've got GitOps at our core. These are the things that we've been doing for a long time. And although the QR code's disappeared there at the bottom, we cover advisory, implementation, pen testing, training. If you want me to train you, that's what we do. That's what I do. We run capture the flags and we do tabletop exercises. We've got a whole bunch of case studies on the QR code there. And you can see our Hacking Kubernetes book by founder and CEO Andy Martin is available as a free download. You can scan the QR code there or on a banner over there. Hopefully, you've all got to the end of this talk and you've gone, now I understand. For everyone who sat down at the start, now I understand what GitOps is. Now I understand how we could start implementing that or how it applies to me. So that if I do this talk again, I don't have the same number of people disappearing all the way through who knows what GitOps is, who uses GitOps principles. And I hope you can take that away with you and learn a little bit more about GitOps. Thank you. There's silence in the room. I like it when there's silence. Oh no, here we go.
If you're not striving to get off, what are you doing? And go to sleep at night, and you think,
It took me a while to get into GitOps. I've been doing DevOps for years and I did not understand why GitOps was such an important thing. But if you do DevOps right, GitOps follows along quite quickly. If you still aren't doing DevOps, GitOps is impossible. And I always think when I talk to people, getting that cultural understanding right, that way of working that DevOps provides, and understanding who your teams are, if you haven't got that, then it's a hurdle too far. And I wonder if that's probably the case for a number of people in the room. One person can't do it. It takes a lot of people to implement. What is a competitive tool? So I talked about Flux tonight, but there are multiple. Argo CD is probably the largest of the GitOps tooling. I'm a little bit biased, but I think Flux CD is probably better. It's lighter. It is a little bit quicker, but Argo CD has UIs. It has all kinds of other things, and it's a little bit simpler to get into at times. But then there's things like Harness, and there are a myriad of tools. Argo is probably the #1 in terms of search, and Flux, I reckon, is #1 in terms of functionality that you get and the performance that you get and the onboarding experience. Any other questions?
so could you elaborate selling aspect in multi-tenant scenarios?
Scaling, the scaling aspect using FluxCD in a multi-tenant environment. Flux can scale. I have heard stories of Flux going up to thousands and thousands of different environments and deployments. But it tends to struggle when you're trying to use one operator to scan multiple source repositories and deploy to lots of different namespaces. So as it gets bigger, and as your Git repositories start to reflect the size of the organization and the complexity that you're trying to deal with, having multiple operators in potentially different namespaces to focus on that namespace allows it to scale and operate more in a more performant way. Hopefully that answered it fine.
No answers, but I guess that answered the question. Yeah, thank you. Cool. Any other questions? Nope. All right. Yeah. Are you doing all the work?
Tools does Flux support other than like how customize because of what we do. Now repository we have like we're using our own tools basically to inject parameters into like cloud formation or using like gunplate, this kind of things. We're not using that like open source one. So that's like our new solutions for that.
I love it when people jump in. Because you talked about templating, and the default for templating and the ones that we support are what most people use, Helm and Customize. Flux works really well with Customize, and you can control a lot of things that Flux does. I don't know whether it deals with other tools. I haven't used it with any other tools specifically, but I'll touch base with you afterwards and see if I can get the answer from some of our maintainers and come back to you with some answers. Because I think the idea of it can monitor multiple different repositories. So if you already got your own tool that does some of that templating, pushes it into the repository, then Flux will be able to see that. It will just be more complicated than it trying to do the templating parameterization at the next level down. So I'll touch base with you after. Yeah. No more hands waving.
Cool. Thank you very much, Rob, for this intro. Please give him a huge round of applause. I'm a huge fan of Flux, but yeah, if you know me, you already know that. So we are going on to the end of the night. So for those who stayed, you have more chance to win one of those prizes. So before you start, if you are not already on the Wi-Fi, scan the QR code because we're going to go on to the quiz. And for the quiz, you will need to have your phone ready, scan the QR code and answer the 10 questions. And if you're right, and if you're the fastest, you have a chance to choose the price you want. Are you all ready? Still see some phones up. If you can't use the QR code, the guest Wi-Fi and the password is there on the left. If you see on the wall, you can type it. That's easier. All right. So we all value your input, so on how we can improve. So if you can take a few seconds to scan this and fill up the form, that would be greatly appreciated. Okay, so start by scanning this QR code. So you will need to fill in, enter your name and an email address, I think. I can't remember. And then from there, once you're all ready, I will start the quiz. Okay, is everybody ready?
Scan again. You'll be able to join without finding it. And again.
Actually, just as a guest mode. In the guest mode, we don't need people to
Yes, everybody's ready. Competition. Give the answer to your.
Yeah, don't give the right answer to your neighbor. I won't give you the answer either. But if you have paid attention to today's two talks, you should be able to answer it easily. All right, are you ready? I still see some faces on the looking at their phone. Yeah, all good already? I'm not going to ask you to stand up if you are ready. All right, let's go. Let's start. First question. 3, 2, 1, get ready. All right, complete the quote. GitOps is the best thing since sliced bread, infrastructure as code, Starbucks, or configuration as code. And the correct answer was configuration as code. I'm surprised nobody said since sliced bread. I think that's the best thing since sliced bread. All right, next question. What isn't a GitOps principle? Pulled automatically, declarative, scale on demand, version, and immutable. Immutable. Going to get it right. Okay, and the correct answer was scale on demand. The first one still Jordan. Yeah, well done. You can keep it. Yeah, but you still have 8 questions, so a lot of things can change, as it usually does. Next one. Which company coined the phrase DevOps? GitOps, sorry. Weaveworks, ControlPlane, Sysdig, Google. And the correct answer was Weaveworks, but they're not there anymore. Next one. Why use GitHub pooled model? Hey, well done. But I would have said like to blame a specific dev for an outage. That's usually the best thing because you have the audit trail and then you can blame them. There's even a function on GitHub to blame people. Anyway, next one. Falco is open source, closed source, subscription based. And the correct answer was open sourced. Next one, what foundation did Falco recently graduated from? SNCF, CNCF, BCF, CNI. I don't know who came up with the name SNCF, but that's the French railway. Cool. So we still have the same people on the first three places. They're very close. Yeah, everything can change. There's still 4 more questions. Let's go. Falco acts as what for your application? A video camera, a fire hose, a security alarm, a battery charger. So the faster and the righter you are, the easier, the one at the top. So, hey, things have changed. I told you. A lot of things have changed. So the correct answer was a video camera. And so now we have Jack Ali, which is leading the pack. Good. Next one. Falco has had been between 10 million and 20 million downloads, 20, 40, 60, 80, 100, and 120 million. Ooh, and the correct answer was between 100 million and 120 million downloads. And things have changed again. 2 more questions. So Loris was the co-founder of Kubernetes, Wireshark, Nginx, Apache. And the correct answer was Wireshark. And last question. Cool. So we are done. But before we wrap up, who knows any of the names that are on this thing or who used that? Only the oldies, yeah. Cool. All right, that's the end of the quiz. So let's finish it. And let's go to the leaderboard. So the winner tonight is in first place, Adam. Where is Adam? Ah, well done.
We got quite a few nice, prize.
Yeah, no.
I mean, which one you like? We also have the total cloud access, which is 6 months of free access. You want any one of these or?
Maybe the code.
Oh, you like a code of cloud 6 months?
Yeah, that sounds good.
Subscription. Yeah, it's a pretty good deal. Yeah, to be honest. Yeah. Yeah, you let us, know your full name, email address. Yeah.
Yeah,
So
speak
some of
to.
us,
Oh yeah.
Yeah, speak to Thiago.
you want to take a photo?
Yeah.
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 The second place is online. All right, let me try to bring the person online if I can.
Yeah, I'm online here. Hi.
Nice. How do you, I get there?
Gajanan, yeah, just me.
Degionanni.
Yes, thank you. Thank you for the.
Hey. I don't know if you,
Sorry?
Gajan, can you speak? Let's see if I can hear you.
Yes, I can. I'm speaking. Can you hear me?
Oh, he's typing. I can hear you now. Typing, Gajan.
Can you hear me now?
Yeah. We can hear you. I'll put you on the mic.
Yeah. Cool. Thank you. Yeah. What do you want me to know?
So there's a bunch of things that you cannot really see.
Yeah.
So you can have them. That's going to be hard to ship it to you.
Yeah.
Or
We can give the code cloud access.
yeah, there's another code cloud access if you're interested in.
Yes, please. Yeah, I'll take that on.
Okay.
Yeah, please let us know your full name, email address.
Yes. Is via chat? Is that okay?
Yeah, that's easier.
To Louisa, yeah.
Cool. Thank you.
Cool. Thank you. Okay, in third place we have Mark. Did he cheat? No. You can't take anything. You're not allowed.
It's all right. It's all right. Yeah. Seriously, it's all right.
Yeah?
Yeah, it's okay.
It's okay then.
Yeah, everyone can. No, Mark, come on, yeah. Good job. Yeah. Which one left? Yeah, just whatever you like, I'll give out a prize. Okay. Thank you. Nice.
Well done. I'm hiding in the.
Thanks, man.
In fourth place, Jack Ali. Where are you, Jack? Ah, well done.
I think we still have one code called access for 6 months. Yeah, if you want to take that one, if you want to learn Kubernetes, I'll let someone else take that. Okay, so what would you like? Yeah, we've got quite a few stuff here. I think this one also,
Oh boy.
maybe Sysdig cap. I don't know. Yeah, I never tried. Yeah. If you like, yeah, that's all good. You might take a photo here. Yeah, we actually really encourage you guys to help us to do LinkedIn posts to help us to promote. And hopefully we can get more sponsors, get more okay.
Okay, now next we have in fifth place, Liu Bao. Where are you, Liu?
What would you like? Yeah, nice. That's a good choice. Cool. You okay? Take a photo here. Yeah. Come over. Thank you. Yeah. Well done.
In sixth place, Makara. Well done.
We still have, I think we still have one, right?
Yeah, we have one, but
He got it last
yeah,
last time.
Yeah, or maybe the cap initialize. I think that was similar, yeah. Okay. Photo,
yeah. Yeah. He got the access last time, so he's doing well.
But he didn't study enough. He's in fifth place this time. Sixth place, sorry. In seventh place, Stefan. Where are you? Where are you, Stefan? Congratulations.
I think only the Lego sets, or maybe anyone over there. So yeah, we also have one nice book. You take this one. Wow, that's a pretty unique one. Yeah, only one.
Only one. Okay,
Okay, so
Where are we stopping? Until everyone has a gift?
I think we still got quite a few. Yeah.
Yeah.
up to the 10th.
Up to the 10th? Yeah.
The 10th.
And we keep for the next round?
Yeah.
Yeah. Cool. So Siddharth, Pat, where are you? Well done. Congratulations.
74 seconds.
That's why. Yeah.
That's why I got the answers wrong.
You were not on the Wi-Fi.
You want to take a call access with loading, much better. Or you want to play? Okay. Yeah, you choose. I'll take this one. Sure. Yeah. Cool. Okay. Photo. Yeah. Photo.
In ninth place, Sam. Congratulations.
Congratulations. What would you like? Yeah, we still have one more the Star Wars set if you want to, or maybe the cap. Okay, cool. All right, thank you. Photo. Yeah. Thank you so much. Thanks everybody. And we still have some a few books
And there's one more, yeah.
Okay.
Yeah, and I don't want to mess with this one.
Yeah. Cool.
I'm not going to mess with this one. Never know. Yeah, his name is Bond, James Bond. Where is he?
And they still have a special edging you cannot put this full name, right? Sorry.
Do you prefer the cool product accessible?
Yeah, have only one last functional access.
Yeah.
Yeah, sure.
Okay.
That's all right.
Okay.
6 months.
Yeah. Come on, next time.
Great.
Thanks, everybody. Before you guys go, do you want to come over? We take a group photo, please. And if anyone actually want the flux,
Oh,
sticker.
yes. That I want.
Yeah. Yeah, go for it. And also some other small stickers. Yeah, feel free to come over. Yeah. We don't have many, but there is.
But let's take a picture before.
Like yeah.
Let's take a photo first.
Yeah.
And then-
Yeah. Let's take a photo.